Regular expressions, or regex for short, looks really scary, but they're really kind of alright once you get to know them. Put simply, they're really just a language-independent way of searching for patterns in strings. They can take quite a bit of thinking about, but they will save you hours and hours of coding to try and find the patterns through code itself. And if you find it really difficult or avoid it like the plague, I get it. I found it one of the hardest things to learn when I was starting out as a developer. So in this one, I plan to demystify regular expressions so you too can master them like a pro. Let's get straight to it. Today I'm going to be working in regex 101, which is a website, but really many programming tools support regex in full. Some support a lower subset, but you'll be able to do most of this in any programming language. The first thing we can talk about are literals. This is where we just search what we want to search for. So if I want to search for the word cat, you can see as I type, it highlights all of the letters that match. And you'll see it's matched cat and the cat in catch. So searching for literals is dead easy. We do that in our code today. So let's move on to something a little more challenging. Let's say we want to find the words cat, bat, and mat. How would we do that? Well, you can use character classes, and that's basically where we say open bracket, close bracket. It's kind of the list thing in Python. And then in there, we're just going to put the letters we want to search for. So C for cat, B for bat, and M for mat. Note that the M is uppercase and regular expressions are case sensitive. So what's that actually saying? Well, it's saying find any of these letters at the starting point of what I'm going to search for. So if we were to add the word bad cat, it would still match that as well. If you want to match many more characters than that, we can also just do capital A to Z, lowercase a to Z, and that will match any starting word. So you can see here we've got dat. So it's anything that now has AT in it. There are some character classes that you don't have to put in square brackets because they're made for you. And some of the examples of these are /s. This will search for any space. So you can see all the white space has now been highlighted. There's /w, which will search for any letter or number, basically any alphanumeric character. There is D itself, which searched just for numbers. And on top of all of those, there is /S for not a space, /D for not a number, /W for not a word. Okay, so back to our example here. You'll see that we've matched cat at the end of a word and cat at the beginning of a word. How do we just match the word we want? There's also some hidden character classes called /B, which stands for word boundary. So if I put one of those at the beginning, it will only match where the word begins with a B, because it's saying start of a word effectively here. And then at the end, we can do another one, and that will only match full words, where there's a word boundary at either side, i.e. the word starts or it stops. And now these are called anchors, and there are some other anchors we can use. One is this one, which is the caret symbol, and that will only match it where we're at the start of a string or the start of a line in our string. And there's also one that will anchor to the end of a line, which is the $. So we put in the $, there, and it's now matched cat at the end of the line. There is also something which is not word boundary. So this will match any cat that is part of another word at the beginning, capital B, and you'll see it's matched our bad cat. Put it at the end, and it will match words that start with cat, but don't finish with it, or have cat in the middle. So there are 4 anchors. Keeping up so far? I told you it's actually pretty easy. Next, we're going to talk about quantifiers. Let's say I want to find the words bait and wait. I can add an I, and actually let's add our W in so it finds it. Now let's say I want to find them whether the I is there or not, so I want to find cat and bat as well. The first quantifier we're going to talk about is the question mark. That basically says I want 0 or 1 I in the string. So you'll see it will either find anything where there is 1 I or there is no I at all. And question mark works on the character that immediately precedes it, so it doesn't affect our A at all. Now, let's say we want to find anything that has A or I in the middle of the word, and we want to find anything that has 2 A's or 2 I's or an A and an I in the middle. Well, we can do brackets, which are dictionary brackets in Python, 2. And that will basically say, find me any word where there is the letters A and I twice in the word. It doesn't have to be just A's, it doesn't have to be just I's. It's a mixture of those two. Now, another way of doing quantifiers is a star, which will match 0 or more occasions of those letters. So that was any number of A's. If we add another cat with loads of A's, it will match that as well. But if we go back to our 2 one, it will not match the long one at the end. And then the last thing we can look at is a plus, and that is 1 or more of the letters. So to recap, a question mark will find 0 or 1 occurrences of a character. So in this case, it's finding either an A or an I, or none of those at all. So this will actually match also CT. A star will match 0 or more. So here you can see it's matched all of the variations of cat, bat, and even CT. And a plus will match 1 or more. So it must have at least one A, it must have at least one I, so our CT now no longer finds. And then we have the way of finding I want exactly 2. Now if you want to find a range of numbers, so you want to find words that either have one A or one I, then we would do 1, 2, which gives it the range. So it says between 1 or 2 times. And we can also say between 1 and 7 till we eventually find cat, the long one at the end. Okay, so that's quantifiers. Before we move on to groups and all the power that they have, we haven't covered one of our meta characters, which is the full stop. And full stop basically says match any character. So that will substitute for any character. And actually, if we take all of our stuff off around it, it matches everything apart from new lines. These new line characters at the end of each line are not highlighted. If you do want to find those new lines, you can do /n. And that'll find all the new line characters at the end of the line. Let's go back to a simpler example where we're just looking for the words cat or bat as a word. So we got our boundary, either a C or a B, an AT, and a /B for another boundary. If we use the caret, which we used before as an anchor, if it's used within a character class, it will say not those letters. So that's searching for anything that isn't a C or a B. So now it's highlighted our capital C and our M. Another one of the meta characters is this one here, which is the OR symbol. And these are used always within groups. So we can look for A, AI, or I. So it's basically saying look for A, look for AI, or look for I, all within this group. We haven't really talked about groups yet, so what are they? They're a way of grouping characters together and then applying stuff to them. So if we put this back to our CB and add W, we now get bait and weight. And we can go back to our question mark to say, I want 0 or 1 of these. And you'll see it now matches CT, but it won't match any one of them. It only matches the group, so A and I together as one. Groups are way more powerful than that. But before we get to talk about that, let us do some searching of some of the strings I've got in here. So in here, I got some email addresses made up at random, I've got some names, and I have some lines from a log file. Well, a fictional log file. So let's say we want to match the IP address at the start of this log file. Well, we can use our /d to say I want digits, and I want 3 of them. Actually, I want 2 or 3 of them. So you can see there, it's looking for digits 2 or 3, but it's finding separate occasions, not one IP address. To find one IP address, we could just repeat this multiple times with a dot between them. So if I copy this. Now to find a dot in a string, because it's a meta character, you need to escape it with a /. And we'll have to do that again, and again, and again. Now this will find our IP address, and if we pull in our panel from the side, you'll see these matches, and it's matched 10.128.223.12, and the next one, which is 214.211.101.18. Now, it hasn't matched this middle one, and that is because that is a 6, so it actually needs to be 1 or 3, and that needs to change through all of our numbers here. And now it's matched all 3 of them. If we want to get each of the number ranges within the IP address, we could do that in our programming language by splitting on the dot, but we can also do it in regular expressions using groups. So if I take this and wrap each of these in a group, you'll see our 10 is now a different colour. I do this again for our next one, and we now have brown, and the next one, until we're all done. And you'll see each one of those is now a different colour, and if we go to our matches and scroll down to the groups under those matches, you'll see that we have 10.128.23.12. Now we can also programmatically look at the groups, so that's a really easy way of saying to our program later that the first 4 groups in these strings are the IP address parts. Now let's expand this to find the rest of the string. So we'll put a space. We could also do /s, remember, but I'm going to use a space. I prefer to use a space because /s matches other things like new line characters and things. And then we want to find a 3 or 4 letter word. These are going to be specific because they're HTTP methods. And we're going to find get, post, or put. There's also more that we'd need to add if our log file had more of these. But we now have another group which tells us the HTTP method. We then want to find another space, and we want to find what looks to be a username. So this is really any word, and actually let's just do a /w any number of times that's at least 1. And let's put this in a group as well, because I want the username to be a separate entity. So let's match our next part of the string. So we're going to look for full stop, which is any character, and we're going to look for plus number of times until we come to an exclamation mark that is at the end of our line. And if we put this in brackets, you'll see our group now has the log entry for that string. So we've really, split out of our document the log entries we care about, but we've also split them out so our program can read each individual element really, really quickly. Groups are incredibly powerful for this. Now, if we didn't care about the IP information, there's a much easier way of finding our IP address. And that is, let's just get our IP address by finding our first blocks, put those in a group, and then we're going to find exactly 3 of them. And then the last one doesn't have a dot at the end. Now, because we got a group in there, it has picked one of them, but we can just ignore that, and we've got our IP address with far fewer pieces of text. Okay, so next let's find our names. Well, they all begin with a capital M, and we're going to look at the start of a line because that's where they all are. So let's put in our caret. And then they either have R or S or both. And we want to find 1 or 2 of those. And then they have a full stop, so we need to escape it. And they either have it or they don't, so that would be a question mark at the end. And then they have a space. And then there is either one letter and then a space, and then another one. So let us get this and wrap it in a group. And then our next name is going to be, there's no numbers in here, so it'll be A to Z or A to Z lowercase. And there will be 1 or more of those. Then we'll have another space, and then we'll just repeat this last sequence here. Now that's only capturing the first letters, and that is because I haven't put my plus inside the group, because it's looking for the first letters with any number of letters after them. So now it's matched the full words, and you can see Mr. James Doyle, Mr. James Doyle in each of the groups. And lastly, let's look at some email addresses. This one is quite common. For the first one, we can just find /W, and then we find an @ symbol, and we want any number of those. Word characters also include an underscore, which is quite handy, but they do not keep dashes. So if we had a dash in our email address, we couldn't use W. Well, we could. We could do that and then that. So we're saying any word character or a dash. Another way of saying that would be capital A to Z, lowercase a to Z, and then 0 to 9 and dash. Dash will always go at the end because remember it's a range if you put it between 2 letters or 2 numbers. Okay, so the first bit is really the identifier of the person. So we're going to stick that in a group because I might want it. The @ symbol we don't really care about. So the next piece is then the domain name. If we do basically what we have here. Now, I just remembered that if we add this one again, you could have dots in your email address. So we need to match those as well. And the way we do that is to just add a dot in here and it'll match it. Now, inside a square bracket, you do not need to escape the dot, although doing so won't harm you. So you can do it if you feel better doing it. And then the last bit is really the registrar that's holding the domain. So that's going to be a dot. And then it's basically going to be this again, but without the dash. And now you'll see we have our email address matched, the owner of the email address, the domain, and then the domain suffix or whatever you want to call it. The last thing I want to show you is look ahead and look behind assertions or negative assertions. These are pretty powerful and don't exist in all languages. So if we go back up to our words here and we simplify this back down to AI to look for wait or bait. What happens if we know that AA is a spelling mistake or II is a spelling mistake and we don't want to capture those? Well, one way of doing it is to do a look-ahead assertion. A look-ahead assertion is always in group brackets and it has a question mark at the start. If it's a positive, i.e. we want to find this, then we would do equals and we can say the next 2 characters must be II. Or if you use an exclamation mark for not, we can say not II or AA. So now it finds bait or wait, but without the misspelled II or AA. Now these can also be done as look back assertions. So if I take this out of here and put it here, to look back, we just put a less than symbol, which points backwards, and that will say the previous 2 characters cannot be an II or an AA. These are a little more advanced and they're not covered in all languages, but Python supports them. Speaking of which, I will be covering how to use regular expressions within Python in my next video. Don't miss out on that, it'll be up top left right now. And with that, thank you for watching, and I hope to catch you on the next one.